everybody, welcome back to Claudia's Math Classroom. Today we're going to wrap up factoring special quadratics. So we're going to talk about a couple more examples of difference of squares and a couple more examples of perfect square trinomials. So let's start with this difference of squares. 1 minus 64x squared. So I've said in previous videos that you should never factor anything that has a leading negative. Now this actually has a leading negative because this is actually the leading term. The reason it's the leading term is because it contains the highest exponent of the two terms. The exponent on this one is x to the power of 0, if you will. So I've always said too that you have to have the leading term first and that you have to factor out leading negatives. Now if I turn this around, I have a leading negative, don't I? And you would never factor it, not like this, okay? You could factor this one, so this is one of the exceptions where you don't actually have to put the leading term up front and the leading term can be negative, as it were. This though, you wouldn't factor it looking like this. So what we're going to do is we're going to take that negative out and we're going to end up with that. Now we have what really looks like difference of squares, right? And so we just go according to the pattern, which is the square root of the first term minus or plus the square root of the second term, and then we do it all again with the opposite sign. Okay, so that's the factored form of that. Now if I decided to not turn the terms around the way that I did here, then I could just factor it up here and I would go 1 minus 8x, 1 plus 8x. And it's the same as this. It doesn't quite look the same, but it is the same. If I took the negative out of this bracket here, I would have negative, and then if I turn those terms around right off the bat, I would have this. Okay, now this is the same as 8x plus 1. Doesn't matter what order you add things in. This here is, of course, 8x minus 1 with the minus out front. So you can see that we end up with the same thing. Okay, in my opinion, this is a better answer because you haven't got that leading, or that negative x. Sorry, this is a better answer because you don't have, this here. Because you haven't got the leading term. X is the leading term. The term with x in it is the leading term. It's not negative here. It is negative here, and leading negatives can cause problems. So either way though, this is an exception to the rule where you absolutely have to have the leading term up front. And in this case, if you decide to factor it like this, then you're actually not taking out that leading negative. It's the only exception to not factoring out a leading negative when factoring anything really, okay? All right, so let's look at the next one then. We have 225y squared minus 49x squared. Now I'm pretty picky with math. You could argue that this is leading term, and the reason for that is because x comes before y in the alphabet. It's not critically important, but convention would have us put this term first, okay? Again, it's not absolutely necessary that we do this, but if we do decide to turn it around, then that leading negative, just like in the last example, has to be taken out. Okay? Now, what we do is we take the square root of the first term, which is 7x, subtract or add the square root of the second term, which is 15y. And then we write the same thing again, just with the opposite sign. Okay, and that's that one factored. Now if you chose to stay with this, that's fine. Here's what it would look like. You would have 15y minus 7x times 15y plus 7x. Okay? Now this is the same as this. It's exactly the same. And this is the same as this. The only difference is we've got the terms turned around and we've got the negative multiplied through in essence. So if I multiply the negative through here, that's what I'd end up with. Okay, And let me turn these two around just so that you can see that it's going to look exactly the same. And then we'll turn these two terms around like that. And you can see that we're ending up with the same thing, okay? In my opinion, this is a better answer. You don't have that leading negative, okay? In the case of the last example where we had one term had a variable and the other term didn't, it was a bit more important. Here, it's more convention that has us list the x before the y, all right? So that's that one. (49) x squared plus 28x plus 4. Okay, so the way that we recognize a perfect square trinomial is to identify the fact that there's a perfect square here, and a perfect square here, and a plus here. Now, this was subject of another video, a couple of videos ago, in which I showed you how to recognize the possibility of a perfect square trinomial. This is definitely possibly a perfect square trinomial. We also have to have a plus sign here or it doesn't work. This sign, it's irrelevant. It could be a minus or a plus. Alright, so we'll take the square root of this number, and we'll take the square root of this number, and we'll get those two. We'll multiply those out to get 14. We'll add 14 to itself, and that is the middle number. So if those two tests work, then you have a perfect square trinomial. So the way that it factors is like this. You take the square root of the first term, you add, because we have a plus here, the square root of the last term. And you put a squared on the outside. Now, of course, it could also be written like this. Take your pick, it doesn't matter. So let's see how the pattern breaks down. So 7x times 7x is 49x squared. 7x times 2 is 14x. And whenever we square a binomial, the two middle terms are going to be the same. So there's that 14x again. And there's my adding the two middle terms together, okay? And then 2 times 2 is 4. And then when we bring those terms together, and I'm about to run out of room here, I think, on the video, we get what we started with. All right? So, you can see how the pattern breaks down. Okay, let's try another one here. Alright, so once again, we've got a perfect square. We're going to take the square root of this, take the square root of this. We're going to multiply them together, add it to itself, and if we're getting that number, we have a perfect square trinomial for sure. So then the way we factor it is we just take the square root of the first term, which is 3x. We subtract, because it's a minus sign, the square root of the second term, which is 8. And we can write the other 3x minus 8 behind it, or we can write it like that. Okay? So that's it for factoring special quadratics. Thanks for watching, and please give my video a thumbs up, and please subscribe to the channel. Also, please share widely so that I can get a more wider viewing audience. All right? Thank you very much, and until next time, thanks.